Hi, in this video, I thought I'll just show you a multisim simulation of a transistor or a BJT specifically working as a switch. Okay, so so this is a very simple circuit, right? Here's a sine wave source, and the amplitude of the sine wave is 0.1 volts. And what I've done is I have put an offset voltage of 1 volt. Okay, so if you want to take a look at this signal, I'm just going to move this probe here and let's take a look at how the signal looks. So it's basically, so this is 0. So this is a 1 volt uh, average voltage and with a zero point 0.1 volt amplitude of the sine wave. Okay, so what I'm going to do is, so this is my signal. I'm going to put it back here, and this signal is actually driving the resistor, but in between I have put a transistor here, and I want to use the transistor as a switch, which means that if the switch is open, what would happen? There should be 0 volts here, right? Because no current would pass through here, and the drop across the resistance would be 0, and you should be getting 0 volts at this voltage. If the switch is open, you should get whatever voltage was here should appear at this point. So I've used the BJT here, and what I've done is I'm giving it a clock source. This clock source is 5 volts in amplitude, so it goes from 0 to 5 volts, and the frequency is 1 hertz. So every 1 second, the signal goes high, and then after 1 second, it goes low again, and so on and so forth. Okay, so let's look at the working of the circuit. So I'm going to run this, and let's look at the graph. So you can see what is happening. So it goes high and then it goes low every second. So high, low, and therefore my circuit is working very well as a switch, right? So that's how you can build a transistor switch.